Inside of every running program is a counterpart to the stack called the heap, like stack memory. Heap memory is also used to store data that is used by a running program, unlike the stack, which is a fixed size area of a memory. The heap can grow and shrink in sizes needed by the process using it. Because of this, the heap is often called a dynamic memory because of its ability to allocate and release blocks of memory on demand. As process could requires the name heap implies this area of memory contains a collection of things piled on top of each other, such as heap of laundry on your bedroom floor. In fact, that's all a memory. So heap is an area of memory used to temporarily store data while a program is running. If you need to store data is more persistent medium, then you will need to write it as a file on a disk, because once a process terminates, its heap memory disappears and everything in it as well. The heap can also used to store as a executive code as well, although this is a very uncommon use of the heap unless you are a programmer who writes buffer overflowing codes. The exact structure of algorithm used to manage the bit it differs between operating system, but the basic concept is that a large area of system memory is allocated for user by a process. When a process is started, the memory area is filled with memory management structure that we call chunks, and each chunk is filled with a header. When the process allocates an area of memory from the heap, which we will call a block, what are more chunks are reserved to create or allocate the requested block of heap memory. The memory address, the beginning of a block, is returned to the program, so it may read and write data to the block and release the blocks of allocated memory back to the heap where no longer needed. So chunks are freed up to the reallocated to other memory blocks which is needed. So you see that the intellectual structure of the heap is very different from the stack. We are ordering position of data item are critical in the stack, so the heap may store data objects at any location without regarding to which chunks are used to store the data of the position for those who chunks amongst other. So objects already stored in the heap, all that is needed for the heap is to have enough free space to store the data object, and the object will then be accessible by memory address in the heap. The memory of the management of the heap memory is therefore the responsibility of the programmer once a process so no longer needs a buffer. The memory used by the buffer should be released to the pool of memory from which it came. One of the pitfalls of the programmer control memory management is the possibility that a memory pointer variable to the heap will be used after the memory has been released. One of the pitfalls of a programmer control memory management is the possibility that a memory pointer variable to the heap will be used after the memory has been released. So the pointer variable will still contain the memory address of the released blocks of that heap memory, but it is no longer valid to use, and if code were attempt to do so, then there will be exploited vulnerability and might result it also possible that could exploit code and also could use the address stored in the pointer to find the heap to mitigate this code should always be written to 0 output pointer and handle variables. After the memory, the reference is free. So exploiting the heap overflow can be achieved by the heap so that it can be overflow just as stack buffer can, and it changes memory address stored in pointer variable, like redirect the flows of program execution, and also cause the process exception handler to be called, and also crash the running process. And the second one is the code stored in heap can be executed, like redirect the instruction pointer to the code, and also find a heap buffer large enough to exploit the code. So in this code there is a many problem, because that could be a potential exploitable vulnerabilities, but the one is to look into this string copy function is the copies of a string of the heap buffer without the first checking how long the string is, or even if it exists on the command line. This means that the string copy function will write whatever input is given to the buffer regardless of the size of the input of the buffer, and which possibly overwriting the other data on the heap. And so if we can control the input characters, the string copy function will then restore, and whatever the code or data we want on the heap, maybe doing so will or won't cause the process to crash, and that's for the experimentation. Determine if this vulnerability is exploitable or not. Unfortunately, this example of poorly designed variable code is all too common in modern software, and therefore so our buffer overflows in this code. So a variable that function pointers, variable that stores in a location of a function, and the function are usually called by the name in a code that process, but then which function is to call in the situation that matters. To call a function, it needs to be addressed but not just by its name, and it will be decided which function to call while program is running, and the function called by name must be hard coded when the software is written. So in this code, I think this code looks weird, but bear with me. This is the declaration for a function pointer variable name callback function, integer parameter 1. So this variable can store a pointer to a function that has one function parameter, and which is an integer variable, and it returns an integer variable in this statement, and because of that it initializes the function properly.